In this video, we're actually going to be carrying out a one sample t-distribution confidence interval. Please remember we use the t-distribution when we have the standard deviation of the sample, noticed by S. We use the z when it's standard deviation of the population. So the very first thing, just like we're going to, like with the z, we're going to define the parameter and context. And since we're working for means, we're going to use mu, the Greek letter mu, in context. We're going to set our writing conditions. These will just say that they are assumed, although in my notes I actually wrote them out. But the things that we have to have is we have to have a random sample. Our sample needs to be less than 10% of the population size, and we need to have a normal population, or n needs to be greater than 30. So one of the two has to be satisfied. The next thing is we'll write our equation, and please note, when we were working with the z, we had x bar plus or minus z star sigma divided by the square root of n. X bar is the same. We changed from a z to the t because this has the standard deviation of the population. This has the standard deviation of the sample. So this is right here, having from the sample is what makes this a t-distribution. Standard deviation of the sample is what makes this a t. Graph and shade, which is sort of optional. If we have data, we need to enter that. We need to make sure we identify our inputs, x bar, standard deviation of the sample, the n, and degrees of freedom. We'll calculate t star. We'll plug in the values. All right. Then we'll calculate the interval, and this is where we're going to go to number 8, which is t interval. We'll write our interval, and then we'll state our conclusion. All right, and our conclusion is going to follow the same format as what we had before. We are 95% confident, or whatever confidence level we have, that the true population mean for whatever it is we're interested in lies within the interval that we calculated. We'll also explain the meaning of the confidence level. In repeated sampling, we expect this mean method will capture the true population mean 95% or whatever our confidence level is. All right, because we believe we have a really good method and we can make that claim. All right, so here we go. We're going to run through our first scenario. So a publishing company has just published a new college textbook. Before the company decides the price at which to sell the textbook, it wants to know the average price of such textbook in the market. The research department at the company took a random sample, so we have an n right here of 36. So n is 36. And collected information on the prices. The information produced a mean price of $70.50. Now this came from the sample. So because this came from the sample, it tells us that our X bar is $70.50. With this standard deviation, a sample standard deviation. Ooh, this is a key word. Sample standard deviation. This means this is an S, which is 45.33. The standard deviation of the sample tells me that I'm going to be working with a t-distribution. So construct a 90% confidence interval for the price of this textbook. So the very first thing on the recipe card said define our parameter. So let mu equal the true population mean price of college textbooks. All right, so this would be number 1. Number 2 is the conditions. Now we're just going to say that they're assumed, but in this particular case, they told me that they had a random sample. All right. Where did it say that? It took a random sample. We have 36 books divided by 0.1, 360. So that means there's at least 360, so that's less than 10%. And they didn't tell me the shape of the population, but n is greater than 30, so it's normal by central limit theorem. Again, for conditions, you can just put number, for number 2, you can write assumed. Here's my list of my data. 70.5, 45.33, N is 36, and I need my degrees of freedom. And remember, your degrees of freedom is just your sample size minus 1. So my sample size is 36. 36 minus 1 is 35. All right, so the next thing I need to do is write my equation, x bar plus or minus t star s divided by square root of n. And then I start plugging in, and I end up with 70.50. I'll leave t star for a moment. I'll come back to it in just a moment. Then I have 45.33 divided by the square root of 36. Well, now I need to calculate t star. All right, and it's going to be very similar to when we calculated z star. But instead, we're going to go second vars, and we're going to go inverse t, which happens to be number 4. Second vars inverse t. And we're supposed to do a comp 90%, so parenthesis 1 minus 0.90 divided by 2. Degrees of freedom are going to be 36 minus 1. And when I end up doing that, I get the value and just make it positive, just like we did for the z. So plus or minus 1.6895. All right, so there's my t star. So then I need to calculate my interval because I've plugged everything in. I'm going to go stats, test, drop down to number 8, which is t interval. So drop all the way down. And 70.5 was my sample mean. My standard deviation, they said, was 45.33. My sample size was 36. And my confidence level was 0.90. And then I calculate, and I end up getting 57.735 and 83.265. So there's my interval. So now that I've done my interval, I need to write my conclusion. Well, what is my conclusion? Well, we are 90% confident that the true population mean for college price for college textbooks lies within the interval $57.73 to $83.26. We can also say that if we did this over and over again and repeated sampling, we expect this method will capture the true population mean price of college textbooks 90% of the time. Now, what happens instead of wanting to do a 95% confidence interval for this type of textbook? Instead of doing a 90, I wanted to do a 95. So I'm going to go ahead and write the 90% down right here. And so our 90% one that we calculated previously was this, 57.735 and 83.265. So that's what we previously calculated. I just wrote it down here because I'm going to slide this up and I want to be able to see it. So then it says calculate a 95%. Well, if I'm calculating a 95%, my X bar is still the same, so 70.50. Come back and we'll get T star in just a moment. We know the standard deviation is 45.33, and we also know our sample size is 36. So I need to go back and calculate T star. So real quickly, T star, second vars, inverse T, and now it's going to be parenthesis 1 minus 0.95 divided by 2. Our degrees of freedom are still the same. And I end up getting 2.030. And then I want to go ahead and run this. So stat, test, number 8 is T interval. And I'm just going to change my confidence level to 0.95. and I end up getting 55. I end up getting this interval right here, which is 55.163. Well, that's lower than 57. And then I have a high side of 85.837, which is higher. So basically, this is lower and this is higher. So this interval got wider. The next one, we're going to do the same thing, but we're going to calculate a 90% interval. Well, if I'm calculating that, I'm still going to have the same X bar, which is still going to be 70.50 plus or minus. We'll come back and do T star in just a moment. We have 45.33 for the standard deviation of the sample, and our sample size was 36. Please remember, because we're working with standard deviation of the sample, that's what makes it a T. So we got to calculate T star. So we're going to go second bars, inverse T, parenthesis, 1 minus 0.99, close parenthesis, divided by 2. Degrees of freedom was our sample size minus 1, so 36 minus 1. And I end up getting a value of 2.7238. 2.7238. So stat test T interval, which is number 8. Sample mean is 70.5, sample standard deviation of 45.33, sample size is 36, and we're changing our confidence level to 0.99. And now we end up with an interval of 49.922. And that's definitely lower than 55, and a high end of 91.078. So basically, in this case, this is lower and this is substantially higher. So this is substantially wider than the previous. So what do we notice about the intervals? Well, they got wider, and they got wider as the confidence level increases, the T statistic increases, and the interval got wider, because we went from a T statistic of 1.69 to 2.03 and 2.7. Because when we did this, the only thing we changed was our level of confidence. We held everything else the same. All right. So as the level of confidence increases, the T statistic increases, and the interval width will also increase. In our next video, we will run a hypothesis test.